All right. So it is 6:50 p.m. Central Time. It is Monday, August 14th. This is session one of Intro to Coding Live JavaScript, the August 2023 session. So we're going to go ahead and jump in here. And what is a programming language? So a programming language lets us write lines of code to give the computer a set of instructions to produce some kind of output. So that output can be text to the screen, creation of a file, printing something, scanning something, sending a file over the internet, anything along those lines. The computer will only perform exactly the instructions you have given it to perform, right? So whatever you tell the computer to do, it is going to do exactly that, no more, no less. And that's what we hope for as a software developer. And the tricky part of our job is trying to figure out how to give the computer step-by-step instructions to do everything we want it to do. One example that I give of that is the difference between a computer trying to make a cup of coffee in the morning and you trying to make a cup of coffee in the morning. And when we make a cup of coffee in the morning, we grab our mug, we throw it in the machine, we throw the coffee pod in the Keurig, we turn the Keurig on, we then hit the brew button, and then we drink our coffee, right? And if we were to tell basically a computer or a robot to do that, we would have to tell it to reach out towards the mug, grab the mug, pick up the mug, move the mug, let go of the mug, grab the coffee pod, move it, and you get this. So that something that we do in 2 or 3 steps can actually be hundreds of instructional steps for a computer. And so starting to think along those lines where we take complex tasks that we take for granted, right? Like I said, just making a cup of coffee, like it seems pretty simple to us, but if you were to write down every single step that you had to take to actually make that cup of coffee, it becomes a fairly complex task. All right, so we're going to jump right in here to values. So every value is a piece of data or a data type, and that data type determines how that value behaves. All right, and so some values are numbers, 86, 2021. Some values are text, or what in JavaScript we will refer to as a string. And so like we can see the name Chris in quotes there, and some values are functions and so on. All right, variables. So now we're going to start to see how we can save values. So variables are named labels and or identifiers for storing values. Remember from math class, the variables X and Y. There are 3 ways to declare create a variable in JavaScript. So you will see out there in all the different like coding websites, like you're Googling a problem, searching for a problem, you will see the var use, so the keyword var. And so this is an older form of JavaScript. It still works today. It's backwards compatible, but we try not to use it when we're writing new code. All right, so it's the most common variable. It can be reassigned, but only accessed within a function. Variables defined with var move to the top when the code is executed. Next, and so this is a more recent version of JavaScript, is let, which is similar to const. The let variable can be reassigned but not redeclared. And then const cannot be reassigned and is not accessible before they appear within the code. And I'm going to show you what all of this looks like in Replit. So var, let, and const are reserved keywords in JavaScript. You can't use them for anything other than declaring variables. So these only ever mean one thing, and they do one very specific thing, which is to declare or start a variable. All right, and so this is what it looks like in Replit. So we've got var x equals hello world, let current year equals 2021, and then const earth gravity equals 9.807. All right, so when we break down what a variable looks like, right? So we've got let, const, and var are the keywords that let you initially declare your variable. You then have to come up with a name for your variable, and then you have to assign your variable a value. All right. And so this is another, and also as I take notes each night, I will then publish my notes in the Slack workspace for everyone in the intro to code. And so you'll also be able to come back and access these. All right. So if I say var x equals 44, right? And if this is my terminal, or I'm sorry, this is my workspace, this is my console. So if I hit the run button here, you won't see anything happen. If I want to see something happen in my console, I will need to send it to the console and log it there, right? So just like you would keep a diary or a log of things. So when I say console.log and I say X, and I run it, now I see my 44 popping up over here, okay? So I've declared my variable X and I've assigned it a value of 44. And when I console.log my variable X, I see my value 44 showing up in the console.log, or I'm sorry, in my console. Now, X is a really bad name for a variable, right? We've come a long way in a very short period of time in computing to the 1950s and 60s, where they used to have to use punch cards, where they actually took cardstock and punched holes in them and then fed them into a machine, and that's how they programmed a computer. To if anyone had the joyous opportunity to own a Commodore 64 when they were a little kid and write a Visual Basic like fireworks program, like over 1,000 lines, and you hit the button and it doesn't work and it's all trashed. Like that was like my first experience with computing when I was little. To now we have these insanely powerful machines. So even if you're buying a low-end laptop today, it is far more powerful than what you need to use the IDE and do basic programming. So we want to be descriptive with how we name things, right? So we could say, turn this to 1981, and we could say date of birth. Now, also please notice how I wrote this. This is called camel case. This is the appropriate syntax or style of writing for JavaScript, right? Like if we were writing Python, we would actually use snake case, and we would do, it would look like this, right? So each word would be separated by an underscore, and that's the same way in Ruby. But when we're writing in JavaScript, we're actually going to be using snake case. So the first word is all lowercase, and then the start of each word after the first word starts with an uppercase letter. All right. So now if I run this, I'm going to get an error, right? And let's read the error message. X is not defined. So I got rid of X up here, but I did not get rid of it right here. So let's go and update this. Now also notice I just typed in the letter D, and Replit is trying to help me out, right? Like it is giving me autocomplete, like, hey, we know you've got something called date of birth. Is that what you're looking for? It is. So let's pick it. Let's run it, 1981. Now, why is it important that we have good variable names? All right, let's go ahead and do this. Let's get this over here so I can do this. All right. So if I hit the run button and I'm going to console.log date of birth, what are some things that we would expect to see over here? If anyone wants to take a stab at it, just shout it out, drop a message in Slack. Just just by reading that, and it's not a trick question, what would we want? If I ran across this variable, what do I expect it to contain? A number, possibly 1991, but it could be anybody's date of birth, right? Like it could be 1972, it could be the year 2000, right? So, but notice how I move this down. We don't know what date of birth looks like, right? So when I hit run, I get banana, right? Because I went up here and I changed date of birth to the string of banana. Now, if I didn't give this a good name, so if I just called this X again, how would I ever know if I'm supposed to get a date of birth, a banana, another function, some complex math? It's impossible for me to tell just because I used a bad variable, right? Versus if I use a good variable name, same thing. If I'm expecting date of birth and I get the string banana that comes out, that tells me that there's probably there's a problem somewhere in my code, right? And so that's why we use good variable name. All right, so, and that is var. And so, and JavaScript is what is referred to as a dynamic language. And so we'll just do this. We'll leave it as var as x is banana. So same thing. So at a later time, I can come in and I can say x is equal to 1941. And then when I console.log x, I'm going to get 1941, right? Because on line 1, I declared the variable x with the string of banana, but I reassigned it the value of the number 1941. How long is too long for a variable name? It really depends. I mean, you don't want it to go crazy. You basically want to say what you need to say in the fewest amount of words possible. But you can, like, for instance, like I'm at work, I'm working on some testing that students take in high school, right? So if I had like a field that required like the student last name and date of birth, like I would say something like student last name and date of birth, right? Like this is really long, but it's also very specific, right? Now, I could shorten this maybe to like DOB or something like that, but this would be still well within the range of acceptable. Like what you don't want is like the first like 3 lines to your favorite song in string form as a variable, right? And so one of the other things too is that, and you'll get this in code Platoon, you'll get this when you become a software developer. There is not a single line of code that I have written that I have put into my software that at least one peer hasn't reviewed for me, right? And so if someone comes along and says, you know, that variable name seems a little long, maybe we could shorten it to something like this. I mean, there's always like, take your best stab at it, and like someone else is going to help you out with it, especially when you're new. And the other side of it is, and this is like a truism in software development, is naming things is hard. Like you will run across things and you will be like, I have no idea what the heck to call this thing, right? And so it's going to pop up, it's going to happen. All right, so that is var. All right, and so here's another thing in Replit. For you Windows users, it is control and then the /, so the one underneath the question mark. And if you're a Mac user, it is command and the /, and that will comment out your code, right? So when you see those 2 green / and then everything turns green, that is a comment. And it means that it is just a note to yourself and the computer no longer recognizes it, right? So if we do this, right, and I get 1941, but if I comment this out where I reassign the value of X and I run this, the computer skips right over it and I'm back to it going from line 1 down here to line 4. So things that are commented out are not interpreted by the computer. It just takes it as like, that's the human writing a note to themselves. I'm going to disregard what's there. All right. Now, if I comment the wrong thing out, I can absolutely cause an error for myself, right? So X is not defined because X no longer exists. Same thing if I do this, right? No, that's interesting. That shouldn't have worked. That is an oddity of Replit. So your normal ID will throw an error there as well. All right. So
yeah, I had a question there. So when you're naming a variable, right, before you define a variable, you have to put var, let, or const in front of it.
Yes, and you should be avoiding var. All right, and so your Replit ran out of resources. Oh boy. All right.
So if we have to avoid var, does it matter with the let or const? Like, how do you know which one is to use better?
That's what we're going to do right now. Okay. So let is basically similar to a like var, where you can reassign the value, right? So I can say we'll call it a Buick, right? And so if I do car type, right, Buick, and now if I say car type equals Ford, right, and I come up here and I run it, now it's Ford, and then I can say car type equals Honda, right, and we can keep going, and it's going to give me the last reassigned value. Now lastly, we'll take a look here at const, right? So const, and we'll say pi, right? Because pi never changes, 3.14, right? And so if I take a look at pi, right, I get my 3.14. And now if I say pi equals 7.59, type error, assignment to a constant variable, and it's throwing an error because I'm trying to change or reassign the value of pi, and a const is telling the computer to block me from doing it. So by default, you want to use const because you cannot reassign the value, right? And now it is easier to use let, because if you always use let, the computer is never going to stop you from reassigning anything. But if, and this is just kind of like a good way to think about it, that if the value doesn't or should not be reassigned, you should start with a const. And you should always start with a const. And then if you run into an issue where it makes sense that that value can actually be reassigned, then you can change it to a let, which is a more permissive way of defining a variable. All right, but why we want to start with const is because it's the safer option. It prevents you from accidentally changing things that you don't mean to change. All right. Let me just go ahead and note this here real quick.
So if you console logged car type in between each time you reassigned it, it would bring up Buick, Ford, and Honda in those like
Yep,
all separately.
sure would. And so because the console.log is just sending a snapshot of what's going on in the program at that time. Right. So computer will always read from left to right, top to bottom. Right. And so now if I do this, and if I leave this, so I've got my error, I should execute all of these lines of code up until here where I hit my error. Right. So Buick, Ford, Honda, then I hit my error. So let me just go ahead and grab this here real quick. All right, and then we can comment this out, and then everything will be right in the world again, and we shouldn't get any errors. All right, so, and if you notice over here, again, really spread throughout here, you can write JavaScript inside of like your Windows text file creator if you want to. I don't recommend it. You're doing it on hard mode at that point, because your IDE has many modern conveniences that make this easier to read, right? So if I grab all of this and I just take this and I'll open up a document here, right? And I paste this in without formatting. This is pretty hard to read, right? Like this is all the same color. It makes it harder to understand what's going on here, right? And inside my IDE, it's doing things to help me out, right? So like this protected keyword, var, let, const, like the equal sign, you can see that they're light blue, right? Like they're telling me that they mean something specific in that language. When I put something in quotes, I'm making it a string, right? And it's this kind of pale orange color. When I type in a number, it's bright green, right? If we haven't gotten there yet, but like if I say, let example equal false, right? Notice how like once I got there, it turned false, a different color, light blue. You'll get the same thing for true because those are Boolean values, and we'll talk about those in a little bit, right? And so my IDE is doing things to try and make my life easier, right? So this is and you don't need to remember this yet, but this is a built-in class. So console is part of the JavaScript programming language. And that .log, that is actually where we're making a function or a method on the console class. So this is a function just like me or you could write right here in this IDE, but someone wrote it 30 years ago, 40 years ago now, and it's part of the underlying language, and it's already there for us so that every time we start up a new file, we don't have to write millions of lines of boilerplate to be productive in the language. All right. And so the same thing for the console, right? So my strings are in white. I get this dark gold color, which is telling me that it's a number over here. So, right. And so like I could say const pi string equals 3.14, right? And then right? So these two things, even though they visually look the same to us, they are not the same thing. That is a number and that is a string, right? And so we'll talk about equality and strict equality here and coming up in a couple of slides. So let's see here, we've got, can you give some examples of when letting a variable can be changed would be beneficial? Can the variable change on its own when the code is running? So yes, you will change, like you will use let a lot. Like this is not something where you'll just see it one and done. There are all types of things where you will see the value change, right? Where maybe so like and I'm not going to code it out right now, but like one of the really easy example is like reversing a string, right? And so when you reverse a string, so if you just say Charles, right? And so string equal Charles, and we need to reverse it. We're going to write a program that takes each letter and then saves it somewhere else. And we're going to need to save that. And because we are going to move the letter C into it, and then we're going to move the letter H into it, then we're going to move the letter A into it, so on. We're going to need to make that a let, because if it was a const, we wouldn't be able to change the value of it. All right. And so, yeah, you will use let a lot, and honestly, let is easier. And I'm just telling you increasing a count or decreasing a count. When we start writing loops, that'll be another way where you'll see the let in variable declaration all the time. I'm just giving you like the best practice, but like honestly, in like day-to-day work, I definitely have some lets in my code that probably should have been const or something. It's not the end of the world. It's just best practice. And so if you can get in the habit of doing that, you're better off right from the beginning. All right, so let's see here. So that was that. All right, so we're there. All right, so outputting a variable's value. So the console.log method, we can pass it one or more pieces of data, variables values, and it will display into the console. And then it returns undefined. Don't worry about this yet, but once we start getting into functions, we'll talk all about what it means to return undefined. All right, so it is 7:17. We're at data types. I am going to go ahead and pause. Well, and actually, before I pause the recording, I'm going to ask, does anyone have any questions on what we just covered?
Just a quick question. Can you hear me?
I can.
Okay. Is constant the safer option because it helps to guard against problems of inheritance down the road?
I don't know how it would intersect with inheritance per se, but what the main safeguard is that it protects you from inadvertently changing a value. So that you write a line of code that changes a value that you didn't intend to, a const will prevent you from doing that.
Okay, because the reason why I ask is because there are global, what did you call them? Anyway, they're
Global variables versus local. Yeah, we're going to
Yes.
cover scope as well. Yep. Global variables are dangerous and you want to avoid them as much as possible. But yes, like a global let variable that different parts of your, and so again, like we're going to get into scope, I think either tonight or Wednesday night, like very, very quickly in class. So I don't want to get too far ahead on concepts, but yeah, we need to, when you're writing software as a best practice, you want it to be as restrictive as possible, just across the board, because like we're going to be writing algorithms here that are maybe 5, 10, 20 lines long for some of the more complicated ones. The software that I work in at work has a couple million lines of code between the front end server and JavaScript and the back end server and Ruby, and thousands of classes at this point. And if you leave a global variable hanging out where any part of the application can change it, there's all sorts of inadvertent changes that can happen or impact data in different parts of the application that you were never meaning to do. So we always want to minimize the scope of what we're working with. So we want to keep things as tight and as restrictive as possible. by using a const over a let when we can, and we want to use a local variable instead of a global variable when we can. And we'll talk more about those. Any other questions before I pause the recording and we take a short break here?
Yeah, I have a quick question. So in regards to the console.log, is that the only variable function that you use to like output variables or to run the program, or are there, more functions that you utilize for that?
No. So with console, there's console.log is the most common one, but
Mhm.
there's actually different levels of it. So console.info, console.warn. There's lots of different ways to use the console class, but also we are only using it for the purposes of Replit and seeing what we're writing over here. Again, like if I go back to the example of what I work on during the day, we're not like console.logs are not allowed in our application, right? So I mean, a million lines of JavaScript code and no console.logs whatsoever, right? So it's a tool that we use right now, and we'll get into why you won't use it later. But this is for educational purposes. And
Okay, that makes sense. So console.log is like mostly like a printing function just to like output it. Okay, I just want to make sure. All right,
Yep.
Thank you.
And when we start talking about functions, then we'll start talking about returning and how that
Yeah.
is different than a console.log.
Yeah, thank you. I'm just
Yep.
appreciate that. That's it.
All right. So it's 7:22. I'm going to pause the recording. All right, everyone, welcome back. It is 7:30 p.m. Central Time. So we're going to continue with session one. We're going to hop right into data types. And so the basics of data types. So we already kind of talked about some of these over in Replit. All right, so we've got let age equal 34. That's a number strings. So one thing I didn't talk about yet is the difference between double quotes, single quotes, and backticks. In some languages, there's a difference between all three of these, Ruby being one of them. However, in JavaScript, double quotes or single quotes are your choice. The one thing I'll throw out to you is that you should try and be consistent. So try not to flip back and forth between them too much. The other part of that is that they do have to match, right? So if I take this, let's go ahead and give this a better name. So we'll call this first name. And if I have a single quote up front and a double quote in the back, and I keep typing here, notice how I'm still there. And that is until I throw that. And so this is going to screw things up, right? And so you always want to, and same thing here, if I change this to a double quote, they will always pair off with each other. And then anything that's outside of the paired quotes will no longer be part of the string, and it should throw an error. Right, so the computer is telling me what is going on, excuse me, down on line 23. All right, and so that's another thing. Let's take another look here at the error code, right? So this is all part of Replit, like that's my little directory tree there. But there's my file index.js, index.js, and it's telling me, hey, something looks weird on line 23. All right, and then it's even going as far in this error to highlight what it's saying it doesn't understand. Right, so I did something that is not syntactically correct, and the computer is trying its hardest to try and give me a heads up on what I did wrong, right? Syntax error, unexpected identifier. It's telling me I have no idea what to do with this underlying code. All right, and same thing, if I get rid of it, and I run it again, all right, I didn't tell it to do anything with first name, but notice my error message is now gone. It's not angry at me anymore. All right. And so that is, again, double quotes, single quotes get treated the same way. Backticks are called string literals, and those are a little bit different. And I'm going to just show you an example here. So we'll go, right. So if I say something like greeting, and I say hello, Charles, right? And then I console.log my greeting, and I run this, and I see hello, Charles down here. Now, what if I want this to say different people's names and I don't want it just hard coded to my name? Well, there's a way around that, and we can basically assign it a value, right? And this will not work because I'm still with double quotes. I get the same thing with single quotes. Right now, it's just reading it as a string, right? But as soon as I take these double quotes and I turn them to backticks, and I now have a string literal, and then I think it's a $sign job. There we go. Maybe I'm not getting a warm and fuzzy about that. Nope, there it is. So didn't change the colors like I'd like it to, but when we use string literals, we can take variables and reference them directly and plug the values in. Right, and see how it's a different color. It's white, it's not that yellow. Same thing here. So we can say car type. Right, so we get hello, Charles. That's a nice looking Honda. Right, so even though we see car type here, when we wrap it in the curly braces and lead it with a $sign, that is, and we do it with just the backtick. So this is the top left button on your keyboard, right? That's a backtick. You will get a string literal. And we'll talk more about these down the road. All right. So Booleans, I kind of talked about this a little bit earlier. True or false are the only two Boolean values, and they are protected. That's why we see, oops, sorry, I don't need this anymore. Right. So if I do something like this, right, and I console.log it, right, I get true down here, but this is the string of the word true. It is not a Boolean value. Right, so notice how it turned light blue here, and same thing if I were to console.log that. Notice how true is that dark gold, and that's how we tell the difference, right? So string, 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 number, string, string, Boolean, right? So strings will show up white over here, other data types will not, right? And notice how we get that kind of orangish color that we get for any string when we type in the Boolean true, and it would be the same thing for false. We get that light blue color with it. All right. Undefined. Undefined is a variable has been declared, but no value has been assigned to it yet. Right. So, and you don't really need to worry about this for this class, but when you declare a variable, right? So when I declare a variable, right, and then I assign it a value, I'm actually doing a shortcut here. This is actually a condensed version of two separate actions. This is declaring my variable. This is assigning my variable a value. All right. And so, and this is the normal way of doing it, Like, this is how I want to see it when you write your code. Like, this is what I would expect. However, what it's actually doing is saying, let, right? And so I can do console.log declared var, right? And I get undefined. And notice this is a different color too. It's gray. And that is because declared var is literally undefined. We have not defined the value. We have not assigned a value to it. Now, same thing if I say declared var equals this, and I run it again, now it is defined. There is a defined and assigned value there. And same thing, like where we did all the different console.logs between the car types. If I do this and then I console.log it, I'll get undefined. Then I'm assigning a value, and then I'm seeing the assigned value, right? So you don't need to get too wrapped around the axle on this. Just know that when you're doing this, it's actually a two-step process on one line. You're declaring the variable, you're assigning it a value. You declare the variable, you assign it a value. All right, and this is the right way to do it. This is how we want to see it. All right, and null. And so, and again, I don't know what computer gods got together, but it's different in different languages. And like some of them are null, some of them are nil. In JavaScript, it is a null value. And all that means that there is explicitly a no value assigned. You know that there is no value assigned, and it intentionally does not have a value assigned to it. Right, and null is protected as well, so it should show up as such. So if we say let null var equal null, see how it turns blue, that's telling us it's a protected value and it has special meaning. And same thing, if I now console.log null var, run this, come over here, we get null, it is white, but notice how it is like a bolder print than the other ones, right? So it's telling us again, this is something different. All right, any questions on some of these basic data types?
What would you use null for?
So I mean, you don't use it very often. And what it is used for is if you have to have something that has a value assigned to it, but cannot have a value, then you would assign it null, right? Basically, because it's needed somewhere else in the application for it to have something assigned to it. And null will often get replaced, or you can use it as a, like there's different ways to kind of come to a conclusion on a function, right? Like if you need 3 different inputs that go into a function for it to work, and you only get 2 of them, then you can output a null value. And that's basically going to tell, correct, like a placeholder, or as basically like what I just described would be a way to tell someone that like your function didn't get everything that it needed, right? And so it's just explicitly it's not a mistake. I didn't miss it. I understand that the variable is there, and yes, I understand that there is no value assigned to it. So that you're just explicitly assigning no value to it, right? Because if you leave it blank, it's undefined, and undefined is it's not null. It sounds weird, but that's what it is. It's just one of the again, where we have to be hyper specific when we're talking to computers. Any other questions in these? All right, so now we're getting into our first data structure. All right, so arrays. So arrays are a list-like object that store values, right? So let tech companies be an array of Apple, Facebook, Microsoft, and Google. All right, so up until this point, the what we were working with was basically just storing one string, one number, one value. All right, and here, let me just get rid of these as well, so we're not too cluttered up. And again, like I said, at the end of class tonight, I will take this, and same with any challenges that we work in class, be it if I lead the class through it, or if you do it on your own, and then we come back and do it as a class together, I will always post all of my solutions. And then if anyone ever comes up with a novel solution for something, I'll also typically ask for permission to post their new solution, or a way that maybe it hadn't occurred to me to solve before, into the intro to coding at the end of the night. We scroll up here back to April-ish, right? So this is each night you'll see all of the challenges that I did, the notes, anything else that we do. And anyone from class, you're more than welcome to comment, paste code in here, talk about things. Right, so and that'll be for each night of class. We'll have something like that in there. All right, and so where were we? So we were going to do an array. All right, so let's go ahead and we'll do let first array equal Charles, Todd, Mo, Nugget. All right, and do we have a clean up button up here? Maybe we keep changing things around in here, so oh boy, I should have done that. Sorry. Index or console. Yeah, they keep moving and changing things in here. I don't see, they used to have a cleanup button that would help you clean up your syntax. But when we're writing code in here, we do want to make sure that like we don't have unnecessary spaces or missing spaces. Like we want to keep our our code as clean as possible. So that means following like standard conventions when we do this, and we'll talk about this more down the road. All right, this is an array. So if I console.log my first array here, there is my array, right? Now, specifically, this is an array of strings. Each value in here is a string. An array can hold things other than strings. And again, this is where we talk about JavaScript being a dynamic language. If I was writing in Java, I would actually have to declare an array of strings, and it could only ever hold strings. And if I put a number or a Boolean in here, it would throw an error message. JavaScript doesn't care. This can be whatever I want. So I can throw a Boolean value in here. I can throw in a number, and I can even throw in another array. All right, and now the same thing when I take a look at this, right? There's my value. So Charles, Todd, Mo, Nugget, my Boolean true, my number 495, and then my nested array with 2 more strings inside. This is going to be the first thing that we do in class tonight that is going to be that you're gonna definitely need to put your thinking caps on for. Arrays have index values, all right? Humans, if I almost everyone in this class, if I told you to count to 10, you would start counting at 1. You would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you tell a computer to start counting, it will always start counting at 0. All right. And write that down. You're going to be banging up against that concept for the next couple of months, or basically the first 6 months of writing code. You start counting from 1, computers start counting from 0. All right. So, and arrays have index values starting at 0. And so the way we say that is, right, so there's 0 indexed. Each element in the array has unique sequential all right. So how many items do I have in my array? Let's count. And we can say 1, 2, 3, 4, 5, 6, 7. Even though the nested array has 2 items inside it, the array itself inside the array just counts as 1 value. So I have 7 items, 7 values stored inside of my array. So if I do .count, it's going to yell at me because .count doesn't exist in JavaScript. That's Ruby. Let's do .length. Like I said, I will screw things up and I will always try and fix them. But if you see me do something screwed up, don't hesitate to point it out to me. I do work in another language primarily, so sometimes I do, especially the built-in functions, I'll get them crisscross sometimes. All right, length is not a function because I don't need that. There we go. So the count is 7. Eric, we can, when we talk about built-ins, we'll talk about that stuff, but that's getting pretty far ahead. So I have 7 items in my array, just like I counted. Now, if I were to look at the number 7 in here, I am going to get undefined. And that is because, and I'm just going to make this a little bit easier for the first go around, so it fits on all on one line, right? So if I comment this out and I say 0, 1, 2, 3, 4, 5, and 6, right? So I have 7 items, 1, 2, 3, 4, 5, 6, 7. But because I started counting at 0, when I'm trying to find the 7th one, it is telling me that it's undefined because there is no value with the index of 7 in here, right? So if I want to look at the last thing in an array with a length of 7, I need to basically do length minus 1 to adjust for that counting at 0. And there's the 6th one. And the same thing, if I want to look at the first value, I'll give it a 0. Right? And so let's go ahead and document this. Right, and so the first element, the last element, and undefined, because I've gone 1 too far. All right, and when we start looping and iterating through arrays, it's very easy to get yourself an undefined value because you counted 1 too many, and we'll we'll talk about how to avoid that. All right. And Eric, I believe that you can pop or push from a const declared array. We'll play around with that when we get to built-in methods, which I think will be Wednesday night on an array. There's a whole section in session 2. I'm sorry, it's session 3, so it's Thursday, where we're actually going to go through all the different built-in methods on an array, and then the 4th session, so next Monday, we're going to go through a bunch of the built-ins on objects, which are even trickier than arrays to initially navigate. So sorry, back to data types, back to here. And so array methods, so pre-built-in function included in JavaScript. I already showed you .length. Eric had mentioned pop or push. So pop and push are used to add and remove values from the back of the array. Shift and unshift are used to add and remove values from the front side of the array. Index of will help you locate a value. It'll tell you what index position it's in. And we can use a splice to remove and add different elements into different parts of the array. All right, we're going to cover a bunch more of this on Thursday night. And so any questions so far on what we've covered with arrays? Right.
So,
go ahead.
I'm sorry, just so I'm clear. So a string is anything that's contained in either tick marks or quotes, and then an array has the capability to house either a single string or multiple strings. Is that right?
It is partially right. So everything you said is right, but on top of that, an array can be empty, right? So let empty array just looks like that. And it can include one string, it can include a billion strings, it can include a mixture of strings, numbers, other arrays, other objects, like anything that is a piece of data in JavaScript, you can store inside of an array. And technically, I mean, there's a limit, somewhere there's a limit in the language on how many elements you can have in there, probably before everything starts to melt down. But for our purposes, like, you can store as much as you want to inside of an array.
All right, thank you.
Yep. Right, so because like this is, I've got 4 strings, a Boolean, and 2 numbers inside this array. Right, and I could keep going. All right, and then any other questions on arrays? And don't worry if the zero index counting is still fuzzy. We're going to go over it multiple times over the coming days here. All right. So next data type that we're going to talk about is objects. And this is a structure of data that can contain many values using a comma separated key value pair. So we can, this is just the structure of an object, what it looks like. So instead of the square brackets, we use curly braces here, and we give it a key, a colon, and a value. And then comma separate and so on. We can keep loading additional keys, right? So we could create an object named employee, or declare the variable employee, and assign it the value of an object with a key, with 3 keys, name, title, and salary. And the value for the name key is Ruthie Cohen, the title is cashier, and the salary is 50,000. All right. So there are multiple data types. There's more than 2. The 2 most common data structures that you will use in JavaScript are arrays and objects. There are more out there. There's sets, and like you can assemble a linked list, and there's some more esoteric stuff out there, but what you'll be using in this class will be arrays and objects. And then as far as data types, again, like a number is a data type, a string is a data type, a Boolean is a data type, undefined is its own data type, and null is its own data type. So there are, I mean, right there, like you've got multiples, right? So definitely more than two. Other languages, so like I said, JavaScript is dynamic. So we can have this this dynamic array that changes size. You can change what's inside of it, the types of values. Like if we were to look at, again, say like Java, we would have to declare an array, specify what type of values can be in the array, and then what the length of that array is. And the actual values can change, but they all have to be the same type. And the length of the array always has to stay the same. And if you want an array that can change lengths, it's a different type of array. Like you actually have to specify it as a different type of array. And so you end up with many more data structures that are all wrapped into one wrapper in JavaScript. And that's why when we talk about if a language is fast or slow, it's because like in Java is a faster language, C# is a faster language because it is a strongly typed language where you are telling the computer to reserve exactly the amount of memory that you need to for the exact type of variable that you're declaring. Whereas languages like Ruby and Python and JavaScript, you declare an array, it's going to pull apart, or it's going to pull aside a chunk of memory, and it doesn't care if it uses all that memory or not. It's just reserved all of it. So by the nature of having a dynamic language, they tend to soak up a little bit more memory, which is, like I said, is fine when we're running these giant AWS servers on the cloud. There's more than enough memory to go around. But if, let's say, you're doing high frequency trading, or you're doing like crypto mining or something like that, where like speed is of the essence, like you're not writing those algorithms in a language like JavaScript. You're going to be writing it in a very strict, very memory conscious language to tackle a problem like that. So like high frequency traders aren't writing their algorithms in JavaScript. All right. And so back to an object. So think of a dictionary. In fact, that's what they call it in Python. So the note for objects is that keys are unique. Inside the braces, there can only be one of each key. All right, so let's go ahead and grab this. Right, and so if I want to console.log employee, which is my object, so again, I've declared my variable and I've assigned it the value of an object with 3 keys in it. Oh, with the Cohen, the invalid or unexpected token. It's because the font that I use doesn't treat it like real quotes. Go. That's better. All right, so there is my object. So key name, key title, key salary, value Ruthie Cohen, value cashier, value 50,000, right? So string, number. So we're storing different things in here, right? And so we could add additional things in here, right? So we could give it another value. Right, so schedule, right? And we could say that's an array of days that she works each week. So we could say like Monday, Tuesday, Thursday, Friday. Right, and so now we've got her upcoming schedule in there. And if we run this. Right, so we've just got the other key in there. Now, just like if I want to see something in my array and I need to access it by the index, objects do not have index values, right? So like if I look at employee 0, right, like this is the first element in here that does not have a 0 index, right? So I get undefined because I need to access it by a key name, right? And so if I say name, right, there's Ruthie Cohen, right? And then same thing, if I were to look at it by salary, right, 50,000. And now we talk about that you can only have one key in here of each type. So it's like, it's basically the key name is unique. So if I take another name and I say Charles Kubiak, right, it won't throw an error message. And it'll probably just say Charles Kubiak because that's the last one when you read from top to bottom. But there's no specific guarantee that this will spit out Charles Kubiak versus Ruthie Cohen. And this is, you don't want to be in a situation where you don't know what you're going to get when you press the button. So this is a no-no, like you can't save multiple values with the one key. You're only ever going to get the one value out of it there. And so you want to make sure that your keys are unique. All right. And just like I use .length up here, like a built-in method, their objects are going to have their own set of built-in methods that we're going to go over as well. And like I said, I believe it's next Monday, we have the whole class is going to be talking about the built-in methods for objects. All right. Any questions on what we've covered in objects so far? Okay. Like I said, don't be shy with the questions. Feel free to throw them out there. All right, so we're going to hop into operators. And so we've already been working with one operator all night tonight so far, right? And that is the assignment operator, right? So we think of equals as like, basically like if I put 5 = 5, that would be true to me. That's how it works in math. That is not how it works in JavaScript and in most programming languages. You are using this to assign a value. So let a = 5, and then if we were to console log a + 4, a turns into 5, it'd be 5 + 4, which is 9, right? So it is only for assigning a variable. And I don't normally capitalize that. So easily confused with comparison operators, so double equals and triple equals, and we're going to talk about those here coming up in a couple of slides. All right, so we also have arithmetic operators, and pretty much just like you would on a calculator, a plus is addition, a minus is subtraction, so 1 + 1 = 2, 3 - 2 = 1. Multiplication is a single asterisk, right? So 5 asterisk 3 is 5 × 3 is 15. An exponent is like sometimes we see it on a computer, like in Excel, like they use the tent, shift 6. That is not the case in JavaScript. It is a double asterisk. And then we also have division, which is the /, a single /. So 10 divided by 2 should be 5. And this is something that maybe you haven't seen before. In a lot of languages, it gets called modulus, but in JavaScript, it's actually a remainder, and it returns the remainder, right? So 10 divided by 3, so 3 × 3 is 9. There's a remainder of 1. So that is basically what the remainder does. Any questions on any of these? All right, logic operators. So now we start to get into some of the nitty gritty of basically control logic that we use to tell the computer to do one thing or another. All right. So if we look at equal or strict equal, so double equals versus triple equals, and then not equal or strict not equal, so exclamation point equal or exclamation point double equal. Does anyone know what this is called in programming?
What?
The exclamation point. There's another word for it in programming because exclamation point is a mouthful to say over and over again.
Well, it means not.
You're correct. It means not. It basically is not equal.
Is it the inverse or?
It's a bang.
It is the inverse, but it is called a bang. Yep, Nika got it. So it is called the bang operator. And so if you ever hear bang equals, that means not equal, right? So if something is true and you put a bang operator in front of it, it will now be false. Right, and that's how we check for something. Like we may have some cases where if we want to do something, if something is true, or we may want to do something else if something is false. Just the way that our brains work, and we're so much more conditioned to deal with true. We want to typically anytime you're looking for something false, there's probably a way to write it where you're looking for true. The exception to that would be where there's lots of different true values and there's only one false value. But we'll talk about this, and we'll also talk about like how linting impacts things like that. All right, so let's go ahead and take a look at this in over here now. So let me go ahead and copy that. All right, so if I say let num1 equal 5 or 5, and we'll say let num2 equal 7, and I say console.log num1 double equals num2. All right, what do we expect to see here? What am I going to see over here when I hit this button?
False.
False.
Yep, false. Or I'm going to get an error because I put a space in between num1 and num2. Trick question. No, that was my fault. False, right? So that's what we expect to see. Now, if I were to take num1 and change that to 7 as well, I would expect to see true. Now, just like we talked about let versus const and global variables versus local variables, we always want to be as restrictive as the case will allow us to. And let me show you why. All right. What do you think we're going to get when I compare these two things right now? I've got a string of the number 7 and the actual number 7.
You're
False.
probably
True.
True. Because
Mm.
equal is only looking at the value. It is not looking at the type. And I think I saw Eric throw it out there earlier. But if we there's type of, which is a built-in method that'll tell you what the type of data that you're working with is. So if we do type of num1, oops, is it num1 dot type of maybe? 1 dot type of. Oh, sorry, someone's got an echo going. Is it because it's all one word? Okay, so I'm just putting a capital letter in there when I shouldn't. Let me just make sure I was able to see it. Yeah, so do There we go. So that's telling me it's a string. And if I look at the type of num2, that's telling me it's a number. Equality double equal only looks at the value of string 7 versus number 7 and says, hey, they're both representations of 7. Good to go. It's true. Right. And that can get you in trouble, right? Like if you're comparing numbers and a string gets mixed in there because you maybe wrote a line of code wrong somewhere else in the program and now you're sending strings through, but that means that you're gumming up your data further down the line. That's a problem, right? So now we talk about becoming more restrictive and we do strict equals. And now we're actually going to check the value and the type of data. There's the false that we're looking for, right? So you always want to use triple equals unless for some reason you have to use double equals, which don't ask me to give you a reason why, because at this point, like if I came to a situation where it was double equals, I'd try and fix it to figure out how I could use triple equals again, right? Like that's just a what we would call a code smell, like literally your code stinks. And maybe it's technically not wrong, but it's starting to smell funny and we should probably look at fixing it before it becomes completely rotten, right? And so we always want to stick with that. Now, and again, this is very easy to conceptualize for us, right? So if I change this back to just the number 5, right? Like we get a false. And if I change this to the number 7, I get a true. Now, if I take the bang operator and put this in, so bang strict equals, so this is not strict equals. When I run this, what should I get over here?
False.
Yep, I'm going to get false. And so in our heads, we have to read num1 is strictly not equal to num2. And in this case, it is. And so we've reversed the polarity of everything. And so it makes it's an extra wrinkle that we have to think about. And it's not a big deal when we're doing like one line of conditional logic, but when we start getting into control flow and if statements where there's multiple ifs and else and there's branching logic patterns, JavaScript doesn't work too hard against it, but languages like Python or Ruby will basically throw warnings like telling you like, hey, try and look at this from the true case instead of the false case when possible. All right, so that is basically equal and strict equal and why we want to use strict equal, and same things apply for not equal and strict not equal. Greater than, less than, greater than, or equal, less than or equal work just how you remember them from math class, right? So we can do the same thing in here. If we say is num1 greater than num2, I should get a false because they're equal, right? But if I say if it's greater than or equal to, right, now I'm going to get a true because 7 is greater than or equal to 7. And if I drop it below that threshold, then I'll go back to false, right? And so, like I said, those kind of work just like we remember them. And then we also have logic sorry, before I move to the next page, any questions on any of these equal, not equal, greater than, less than? All right, cool. And all right, nothing in the chat. All right, so last thing in the operator section here is going to be the logical and logical or. All right, so this is an ampersand. This is a pipe. All right, so double ampersand is and, double pipe is or. So let's go ahead and take a look at this example real quick. So if A, and let's go ahead and do this here. What we say is 4 greater than 2 and is 2 less than 8. Right, so that's what this is asking. And this is true, right? So this is true, 4 is greater than 2, and 2 is less than 8. Those are both true. Right, now if we come down here and we say is 4 greater than 8, and is 4 greater than 2, right? This is false. This is true, right? So, and you can have multiple ands. So we could do another and in here, and we could string them on for forever. And you can have 1 million of these resolve to true. And if one of them resolves to false, the whole thing is false. And that is what and means, that every case that you're testing against has to be true or the whole thing is false. There is no strictly greater than or strictly less than. So with those operators, you can put a string in there, but you shouldn't be putting strings in there. And that's because behind the scenes, every string combination resolves to like some sort of a numerical value that JavaScript assigns it, and it doesn't necessarily make any sense. But yeah, there is no strictly with those. And then, or only one of them has to be true, right? So 4 is greater than 2, that's true, or 2 is less than 8, that's true. So either one of them, but they both are, so we get true. But again, this is false. 4 is not greater than 8, but this is true. So, and all of them have to be true or the whole thing is false. And with or, you can have a million falses, but if you have one true, you'll get to true. Okay, and let me throw something here in the class notes. All right, so as long as one of them resolves to false, the whole thing's false. And to get to the double pipes, that is the shift backslash, so like the key right above the enter. All right. And that's logical and logical or. Any questions on that? Well, Nika, the upside is that it doesn't go any further than this, so. Because if you ask me to write like a geometric proof or some sort of a theorem, I would probably couldn't do it to save my life or my job at this point. All right. So functions. And let's see, I believe we've got functions and control flow. We may or may not make it to iteration tonight, but that's okay. We don't have a ton to talk about Wednesday, so usually some of this stuff will carry over into it. All right, functions. What are functions? Functions use case reusable blocks of code that perform specific sets of instructions that you define or that are built into the language, right? So reusable block of code that I write, or it can be a reusable block of code that's already been built into the language, right? So we talked about this, console.log is a built-in function. When I use .length to check the length of my array, that is a built-in function. There's someone already wrote the code for that for me, and it's all behind the scenes, but it's still there. All right. Functions can be defined to accept 0 or more inputs or parameters, and in most cases, output a return value. To declare a new function, use the function keyword followed by the name of the function. That is the old way of doing it. I don't care how you declare a function in this class. We'll cover the different ways that you can do it. There's an old way and there's a new way, just like the difference between var and let and const. When a return statement is encountered, the function exits immediately, returning the return value. All right, so this is the basic boilerplate for a function right here. So let's go ahead and take a look at that. Bonus points. Anyone want to tell me what this function is doing? Like, there aren't any good names in here that tell you what it's doing, but if you read through it, you might be able to figure it out.
It's adding param1 and param2 and returning the value.
Yep, that is correct. So, right, we can key in on this mathematical operator. Param1 and param2 don't really help us, so technically we don't know if strings are coming in here or if it's supposed to be adding numbers, and it's assigning it to a variable value, and then we're returning value out of here. All right, and so when we take a look here, this is what the function declaration looks like, and then we're going to call or invoke the function. Nothing happens when you write a function. You have to call the function to make something happen, and then when we call a function, we pass in the arguments, right? So when we call it name, so we name the function name, and then we pass in the values 1 and 2. So param1 and param2 become the numbers 1 and 2. We add 1 and 2 together, which gives us the value of 3, and the number 3 is returned. All right, so let's go ahead and take a look at this real quick. These out. All right, so we can declare a function like this, and we'll just call it add, and we'll call it num1 and num2, right? So this gives me a better idea of what we're doing here, right? And so when we add two numbers together, we get a sum, right? So we could say sum equals num1 plus num2, and then we can return sum, right? If I hit the run button, nothing happens. All I have done, so when I hit the run button, the computer starts up here, or the interpreter starts up here, and it starts reading through line by line. And it automatically ignores all of these, and it takes each of these variables and it saves them to memory. And then it reassigns them as I tell it to, and it gets all the way down here, and it sees this function, and it takes this function called add and saves it to a block of memory. And then that's the last line of my program. Nothing ever happens. So we saved the function to memory, the computer knows that it exists, but we didn't tell the computer to do anything with it. So what we need to do is call our function, right? Which is by typing out the name of our function. And then if we have parameters that need to be passed in, right? And so I could just do something like this, right? And I could say 3 plus 5. And all this will ever do is return the number 8. So it's not a very useful function, right? Like I can't use it to do anything other than to add the number 3 and 5 together. And if I ever want to change it, I have to come back into my code and change those two hard-coded values, right? So let's change this back to num1 and num2. Now, if I run this and I do not pass any values in, right? Well, sorry. We'll skip that for just a second. I'll come back to that. Let's go ahead and do this first. So when I do this and I hit run, nothing showed up in the console over here, right? And that is because I am returning out of this function, right? It is adding the numbers 3 and 4 together, and it is returning the number 7, but I am not displaying it anywhere. I am not displaying it in my console. So return doesn't guarantee that you'll see something over here in the console. And the way that we will tackle that in this class is whenever you call a function, right, we will console.log our function call. And the reason we want to do it here and not up here, right? So, because I could do the same thing here. So I could get rid of this return and I could say console.log sum, and then I can get rid of my console.log down here, right? Oh, spelling error. I still get the number 7 over here, right? But watch this. So if I console.log my actual function call now, I get undefined. And that means that my function, basically when I console.log add 3 and 4, it is not returning anything. So the value is undefined. So just because I see it over here doesn't mean that I'm actually returning the value. So here's some more proof, right? So let's go triple equals 7. I know that this is adding 3 plus 4, and it is going to console.log 7 out of here. When I do this, I hope I get false, otherwise I'm going to look silly, right? And because what I'm doing is I am comparing undefined to 7, right? And so we always want to return out of our function, right? Like we do not console.log out of our function. Now, while you're writing the function, you can use console.logs in here to figure out what's going on, or there may be some problems that you're trying to troubleshoot. And we'll talk about that as we move forward. But the last thing that is in your function should always be a return. Otherwise, it will just return undefined. Now that I've fixed that, I get true because I'm returning 7 out of here. So even though we read this as humans, we see console.log add 3, 4, triple equals to 7, and we get true. What the computer is seeing is this. It's basically, it's going to get here, it's going to do the math, and it's going to replace add 3, 4 with the number 7, and then it's going to compare it strictly equal to 7, right? So just like when we see num1, num2, we're not actually adding the words num1 and num2 together. Those are variables, they're parameters that stand in for the parameters and inputs that we're giving it, right? So what the computer sees is add 3, 4, and then sum is equal to 3 plus 4, and then we return 7, right? So we're not returning sum, we're actually returning the value 7 out of here. And so these are just placeholders for the actual values that we want it to work with. And by using placeholders and using these variables and making this dynamic, I can say add 3, 4. I can then also turn around and say big long number plus other big long number, and it won't equal 7 anymore, right? But like it'll still add those numbers together for me, and I can swap it out for whatever. And so now if I gave you an array of 50 numbers or 50 pairs of numbers that you needed to add together, instead of doing them all add 3, 4, one at a time, and then the next pair of numbers, we could, and we're going to get into iteration, and we write a loop that picks out each pair in the array and then calls this function over and over again. So it does all of that addition for us automatically. And so instead of needing 50 lines of code that it adds each individual pair separately, we could write it in a couple lines of code that will iteratively go through all of it and give us all the addition that we need. All right. And we're not done with functions yet, but any questions on what I just covered with this right here?
Question. Okay. I'm trying to make sure I understand. So if you do the console.log, but you have a console.log in the function as well, is it almost like it's canceling each other out?
No.
Oh, okay.
So console.log is a built-in function that sends information to the console. All right. And so here, we'll put this in writing.
Is it wrong for me to think of it like a
You're
double?
gonna cancel each other out. So that part I wouldn't like, I wouldn't think that way. So a console.log, right? And right now everything we're developing is in the console, right? But like if like right now, so like if I go to like Amazon, right? And all of this information is coming from a backend server at Amazon to the front end, right? And it is being displayed on the website very quickly. And so all of this information could also be displayed for a developer at Amazon in their console on their local machine. And you could see the raw text and all of the unformatted stuff in the console if they were sending it to the console, right? But once you start writing production level code, you will never send anything to the console ever again, right? So, and you will work with functions for the rest of your life, and your functions will return information, but you will not send it to the console. So this is only a temporary training tool, right? And what I'm saying is that you need to return information out of your function. And we can then console.log that information, right? So if we say add 3, 4 is our function call, right? And then we're sending the results of our function calls to the console. If I get rid of this console.log, the computer still added 3 and 4 together for me. I just did not send that information over there, right? So I could say, right, I could assign my function to a variable, and then at a later date, I could come back and I could do it.
Right.
Right. So I've permanently saved that information. But if you do not return out of your function and you put your console.log in here, you are not actually completing the function. You are not returning the information out of it. You'll see the 7, but notice how we get these undefined, right? And that is what happens when you console.log this. And we're saving this will only resolve to another value if you return that value from the function. Because I console.logged instead of returned, this resolves to undefined. So literally the computer sees this because I did not return out of here.
So it's more like it's just one of those things that has to do with the programming language itself, like a reserved keyword or something like that.
Yes. Well, and
Okay.
it is something that has to do with the programming, and every programming language works this way. Like every programming language has a way to display information in your development console,
Mhm.
and every language has a way to return data from a function. And so, and that's what I guess, like, I mean, if it's confusing, just remember that you always want to return your data out of your function, and you want to wrap your function call inside of the console.log.
Okay. Fair enough. Thank you.
Right. And so to continue on with what we're doing with the function, I believe it says it back here. When a return statement is encountered, the function exits immediately, returning the return value, right? A return statement is the last thing a function will ever do, right? So if I come down here and then I want to do sum divided by 5, right? Is it going to yell at me? Might not yell at me in Replit. Should He used to yell at me in Replit, but we can do it in VS Code here real quick. So that is, it's unreachable code. And so nothing after it. Right, so if I take this function over here, and this is VS Code, what I talked about at the beginning of class. Now, this is what Replit should be doing, but notice how, and the colors are a little bit different, but notice, and here, I'm sorry, let me bump this up for everyone a little bit. Right, so this is nice and bright, and this dimmed out, and if I hold my mouse over it, it says unreachable code detected. So what this is telling me is that the return, as soon as, and I can run through however many lines of code that I want to, right? And I hit the return, it is the last thing I will do in this function. Everything after this is no longer reachable, right? So we can even say, oops. Right, but notice how it is grayed out. And so if I do add 6 and 4, and I do save it, and I say node day1.js, right? So function happened, nothing output, right? Because it stopped here at this return. And same thing, if I take this and I wrap it in a console.log. Right, so there's my 10. So there is my return of sum. 6 plus 4 is 10. Everything below this. Right, notice how it's going from bright to dark. This is all unreachable code. It'll never execute. All right, and so comment this out. Any code all right. So that's that. And let's see here. All right, so last thing on functions here is I talked about this is the old way of doing things. All right, and I don't care which way you use. I will flip back and forth between them in class, depending on how I feel that day. If you ever see me write a function one way or the other and you do not understand it, please stop me. I'm more than happy to rewrite it for you in a way that you understand it. But I do want you to get comfortable seeing it both ways. And I do apologize. I know we're pretty late in the first day of class. And I didn't ask, but is this big enough for everyone in class? Like you guys can read what I'm writing and everything.
Yep.
All right, cool. So, and if I ever pull something up and it's too small or whatever, it's unreadable, let me know and I'll do what I can to adjust sizes. Like all of this stuff is adjustable. All right, so let's go ahead and let's say function subtract. And we'll say num1, num2. We probably won't move over till VS Code. You can move over to VS Code whenever you'd like to. I encourage it. But I'll probably do it on day 8 or 9 or class, like the second to last day or the last day. Because I think it's good for you to see it, but it's not the primary reason for the class. But the sooner you can get to VS Code instead of using Replit, the better off you will be as you prepare for your journey to move forward. You are very limited with Replit. All right. So, and then we could say, and also when we say let, what do you get when you subtract numbers? You knew it was a sum when you did addition. What do you call it when you subtract?
Difference.
All right, sounds good to me. If it's not right, you got me fooled. So num1 minus num2, and then return difference, right? And so if I console.log subtract 10 and 5, let me comment this one out, and I run this, I get, there's my 5, right? Now this, again, this is the first function I've written for anyone in the class. This is a bit overkill. I would not create this variable other than for the illustrative purposes. I would probably just do something like this. Right, this is more of a one-line function where we can just return num1 minus num2, right? And we still get 5, it still works the exact same way. All right, now this is ES5 syntax, still extremely common. All right, we now also have ES6 syntax. Which is also called a fat arrow function. And that is the fat arrow. All right. And so I can say something like const subtract equals num1, num2, fat arrow, right? And we'll call this subtract ES6. And so now if we say subtract ES6, I still get 5, right? This function does the exact same thing as this function. This is just a more modern syntax, right? And now where I will say there is a little bit of a difference is, so ES5, so all functions can have 0+ parameters. Sorry, when writing code, how? So, yeah, basically, these things can be named whatever you want them to be. They're just like if at the very beginning of class, right? So we assign a variable const example 3, and we say Charles, right? Or I guess we can just call this first name, right? And if I console.log first name, I don't expect to see first name over here. I expect to see Charles, right? Because first name is just the label for the value Charles, right? So num1 and num2 are just labels for the numbers that I'm going to be subtracting or adding together, right? Like I could call this, and again, we talk about good naming versus bad naming, right? But I could call this ham and cheese, right? And that doesn't help me do anything. But when I run this function, I'm still going to subtract 10 minus 5 and get 5, right? So we want to give good descriptive labels so people understand what's going on, right? And so like, what are the two numbers in subtraction? What are the two numbers you subtracted? So subtrahend is defined as a term used to denote the number being subtracted from the other, right? So in this given equation above, the subtrahend and the minuend. I would have never remembered that ever for my life, right? So I could, if I wanted to get more specific, right? I could name that these, because unlike addition, where it doesn't matter what order the numbers are added in, right? Like 10 plus 5 or 5 plus 10 is both 15, but 5 minus 10 and 10 minus 5 will give you two very different numbers, right? We could do something like this, right? And this is even more accurate. But it just goes to show you, like, so I rename these again. I'm still at the end of the day, the minuend becomes 10, the subtrahend becomes 5, and I'm still subtracting 10 minus 5. Does that help clear it up a little bit? Okay, so that's where we're at with that. And then kind of like what I was saying, when you say the UI, I'm not sure what you mean by that. And the UI is the user interface. And like right now, we're not really working with the UI. Like the UI is the console. So I don't know if you wanna. Okay. Yeah, and I mean, if there's more, you can always Slack me directly, or when we get to the end of class, I'm more than happy to answer more in-depth questions. All right, so fat arrow function, this does the same as this. We also have an anonymous function, which you don't need to worry about for this class. I'm not going to make you write any anonymous functions, and quite honestly, you don't see these very often at the top level of an application anymore. We'll talk about where these do get used when we get to that, when we start talking about built-in functions and callback functions. All right, so we are at 8:55, so I am going to stop here for the night. When we come back on Wednesday, we'll have control flow, iteration, built-in methods, problem solving, and then session 2, which is the REPL intro, which honestly, we've already covered a bunch of that. So we are going to call it at control flow. I hope everyone got something from this. I know it comes fast and furious the first night, so it's a lot of talking. But like I said, after tonight, pretty much like the first half hour to an hour of class is going to be talking, and then the other 2.5 hours is going to be digging into challenges and actually solving algorithmic problems. And that is where we'll really start to kind of stretch how we think about problem solving in a manner that's appropriate for JavaScript. So I'm going to ask if there's any questions. I'm happy to answer them now. If not, I'm going to stop the recording, and then I'm more than happy to hang out as long as anyone wants to, that they've got additional questions. So class is definitely over at 9. If I cover anything earth-shattering after 9 o'clock, rest assured I will also cover it again in the next class if someone brings up a good point or anything like that. So you don't have to stick around after 9, but if anyone's got any burning questions that they want to ask, I'm here to help and answer questions. So any questions before I stop recording?
Just one quick question.
Yes, sir.
Could you show visually how we would access the notes that you will provide?
Yep, absolutely. So I am going to take this link, and I am going to come into here, and we're going to say ICL JS 1, and we'll say class notes. And there you go. So that is out for everyone. And if you click on that link, it should take you right into the notes, and you can copy paste them. You can fork my replit, I believe. So you should be able, here, let's see here real quick. If I go into one that's not mine, you should see at the top right of the replit, you should see a fork, and then you will take a copy of it. I wouldn't fork it. Yeah, actually, you're good to fork it. I don't really have anything to add to the notes at this point in the evening. So you can fork it, and you've got your own permanent copy of it. But that, I don't delete those links. You can go back and look at previous links from classes that I've been teaching for the past couple of years now.
Thank you.
Yep. Any other questions that we have?
Yes. You did say that you were going to talk about when to apply some of these logics, or how to figure out what the challenges are asking you of. Will that be later on or tomorrow?
Well, no class tomorrow, so don't show up tomorrow. But class Wednesday, yeah. So we're just gonna keep going, right? So I believe I stopped at control flow. So we're gonna get into control flow first thing on Wednesday evening, and we're gonna start talking about if-else statements and how we basically program a computer so that it can make different decisions and produce different outcomes depending on the information that you give it. And then we'll do iteration, which is looping. And then yeah, built-in methods. We'll talk about some more basic computer problem solving. And then, like I said, a quick combo about formatting and clean code, and then that is it. And then we're gonna start tearing into problems. Right, and the list of problems are basically right here. They go from easiest to hardest. And some of the easy ones, like first name, last name, you should be able to tackle even after that. You can work ahead if you want to, but I try not to answer too many questions about the stuff when you're working ahead, because I still have to explain it to the whole class. But if you've ever got any challenges that aren't on this list that you're working on, I'm always happy to see a new challenge. And we'll talk about where you can find some challenges other than this list tomorrow or on Wednesday as well. Any other questions? All right, I'm going to go ahead and stop the recording.